Now we'll start the derivation of interference of light wave. There is a screen and there is a source. This is a point source and which emit light in this direction. This is S1. Suppose there is a point P. Now we have to identify here this point is give brightness or this point is give darkness. That means this point we will get maximum brightness or minimum brightness, constructive interference or destructive interference we will store here. So there is a source and this wave traveling this direction, clear, and another wave is here, this source and traveling here, this point, clear. And if this is suppose wave y1 and this is suppose wave y2 and this is wave y1 and this is wave y2, when crest of one wave and crest of another wave are coincide, then we get maximum intensity, amplitude increase. But when one crest and one drop reach at this point, then we get minimum intensity. Now we have to show here how we get minimum intensity and how can we get maximum intensity at this point, at particular point P. Suppose there is two wave and that is y1, we can write here amplitude, suppose here a1 sin omega t, and second wave we can write here a2 sin omega t plus phi. What is plus phi? Plus phi means second wave which is traveling with a constant phase and this phase is phi, and here phase difference we can write phase difference here phi 2 minus phi 1 which is equal to, if this is suppose phi 1 and this is here phi 2, then phi 2 minus phi 1 is phi, and here phase difference between two wave is phi. So we have to use for interference the medium should be equal, the ray traveling in this direction, this slit are very close to each other, this slit should be narrower in shape, then this source should be point source, and here the frequency is equal, clear, and this source should be important characteristic, that is coherent. Coherent means phase difference throughout the wave remain constant, here phase difference is y. Now using superposition principle, according to superposition principle we can write that is y net equal to or y equal to y net, y equal to y1 plus y2. By using this principle we can solve here. So y equal to y1 plus y2, which a1 sin omega t plus a2 sin omega t plus phi, and here a1 sin omega t plus a2 sin omega t plus phi, sin a plus b, sin a plus b formula sin omega t sin a cos b plus cos a, that is sin b, clear. This is formula of sin a plus b. We have to use here identity, trigonometric identity. Now here we have to use a2 and here another term, that is a2, clear. Okay, now again here sin omega t and this point also sin omega t, if we take common, here we can write a1 plus a2 cos phi into sin omega t is common, so you can write here that is sin omega t plus and another term, that is a2 a2 you can write here sin phi into cos omega t. This is y. But we have to find a general equation, or we have to find a equation, or this is two equation, and by using superposition principle we get a resultant wave, and the resultant wave we have to find here, that is y net or y which is equal to a net. A net means maximum amplitude, here amplitude a1, amplitude a2. Now we have to find maximum amplitude into sin omega t plus theta or something like this, clear. So we have to derive a relation here. Now we have to use here, suppose this is equation number 1. Now let a1 plus a2 cos phi, suppose a I am taking here a cos theta. Why I am taking here? You will clear after a few minutes. A1 plus A2 cos phi, we have to take A cos theta. We already discussed in first chapter also. And there is another term A2 sin phi, and it can be taken, that is A sin theta. Now use this equation number 2 and equation number 3 in equation 1. Then equation 1, from 1 by using 2 and 3 we get it is y equal to a1 plus a2 cos phi, a1 plus a2 cos phi, which is equal to a cos theta into here, that is sin omega t plus a2 sin phi, a2 sin phi equal to a sin theta, and is here, that is cos omega t. Now look at this relation. So y equal to, we can write here a constant quantity, or we can write, if we rearrange this term, sin omega t into cos theta plus here cos omega t into sin theta. This is sin A cos B cos A sin B. Again we use the identity of sin A plus B. So here we have to, so we take here, this is A cos theta and A sin theta. To derive the general equation, you have to remember this concept. So here y net or y equal to A sin omega t sin A cos B cos A sin B, that means sin A plus B sin A plus B, and here sin A plus B sin plus theta. Clear? This is general expression of superposition of wave. That means there is one wave like this, another wave like this. After superposition we get a final wave, and this wave equation, that is y, and here y1 and this is y2. So this y is here y, a sin omega t plus phi. Clear? Now we have to find the value of a, and we have to find the value of theta, because theta and a is here unknown quantity. Now from equation 2 and 3, now squaring equation 2 and 3 and adding them. Now if you square this relation, then you can write a1 plus a2 here cos phi whole square plus another term here sin a2 sin phi and whole square, which is equal to, again right hand side, a square cos square theta plus and a square sin square theta. And here if we take common a square, then cos square theta plus sin square theta, which is equal to 1, and here we get a square, but we have to find the value of a. So here the another term, that is a plus b whole square, this is a square, and we can write here a plus b whole square means a square plus b square, a square plus b square plus 2, a is a1, b it is a2 cos phi, a square plus b square plus 2ab cos phi plus here a2 square, and here that is sin square phi, which is equal to here term, that is a square. Now if you write here a square equal to here cos square phi and here sin square phi, but here a2 square is common quantity, so you can write a1 square plus a2 square common, then the remaining part cos square phi plus here that is sin square phi plus 2a1 a2 cos phi, 2a1 a2 cos phi, and here cos square phi and sin square phi 1, then we get a. This is maximum amplitude a, and a is here, or you can write a net or you can write here A net means net amplitude, or you can write here net, A net, net. So A net or A equal to A1 square plus A2 square plus 2A1 A2 cos phi, 2A1 A2 cos phi under root. And this is the important relation to get maximum amplitude of superposition of two waves. And what is phi is here? Phi is here the phase difference between two waves. Clear? So we get A. Now we have to find theta. Now dividing, right? I am writing here, dividing equation 3, dividing equation 3 by 2, and this is equation number 3. So can write here, that is A2 sin phi divided by his here, that is divided by A1 plus A2 cos phi, A1 plus A2 cos phi equal to A sin theta divided by A cos theta, A cos theta, A cancel, sin by cos equal to tan, which is equal to tan theta, and tan theta equal to A2 sin phi by A1 plus A2 cos phi. Or we can write here theta equal to tan inverse, theta equal to tan inverse, it is A2 sin phi divided by A1 plus A2 cos phi. So we get also theta. Clear? Here we get theta, and here we get, this is relation which is equal to, this relation is A net. That means if you want to clearly understand here, suppose if you draw a diagram here, suppose here y1, this is y1 and this is y2, because here y2 is a phase difference of phi. That means here y2 is moving a phase angle of phi with the y1. So this is y and this is suppose y2, and there is a phase difference, that is phi. And if we draw like a parallelogram, actually this is not, this amplitude is not vector, this amplitude is not vector, and we have to use parallelogram condition, then we get a resultant, and this resultant is known as A net or A, and this angle is known as theta, and theta give here direction of resultant wave. And what is phi? And phi is the angle between, suppose this is A1 and this is A2. Clear? The magnitude or amplitude of two wave is angle phi, or you can say angle, the phase difference between y1 and y2. Clear? So you have to remember this term, this is important term. So we get the resultant, this is the resultant equation, resultant wave equation. Clear? Now we will start constructive interference and destructive interference. So we have a relation, that is A net or A, simple A or A net, which is equal to A1 square A2 square 2A1 A2 cos phi under root. Clear? So for constructive interference, we have to find maximum intensity of light. Here for constructive interference, we get maximum intensity of light. So because intensity of light is directly proportional to A square, if we get maximum amplitude, then we get maximum intensity. So at that time here A net will be A maximum. First we have to find maximum amplitude. So what is the condition for which this term will be maximum? For maximum, A net will be maximum or A max when here the term cos phi, because this A net depends on this cos phi, and this value or maximum value which is +1 and minimum value which is -1. So we can write here when the value of cos phi will be +1, then we get constructive interference, at that time a net or a net we can write here, that is a1 square plus a2 square plus 2a1 a2 here cos phi, which is equal to 1. So cos phi 1 we can write here a1 a2 a square plus b square plus 2ab, which is equal to a1 plus a2 whole square, which is equal to a net. This is the expression for maximum amplitude. And at that time when cos phi equal to 1, or we can write that it's cos 2n pi, cos 2n pi, where n equal to 0, 1, 2, 3. If you use 0, then cos 0 equal to 1, then this term. If you 1, then cos 2 pi, cos 2 pi, which is equal to 1, then cos 2 to the 4 pi, which is equal to 1, then 3 to the 6 pi, which is equal to 1. Clear? So here we can write, this is cos cancel, and phi is here, which is equal to 2n pi. This is important relation. Clear? You have to remember this relation here. So phi equal to 2n pi. If we use this value, then phi will be, first if you use 0, then 0, then if you use 1, then 2 pi, 4 pi, 6 pi, then 8 pi, and so on. If phase difference between two waves, here we can write, if phase difference between two waves is 0, 2 pi, 4 pi, 6 pi, 8 pi, and so on, we get constructive interference. Clear? And there is a relation, that is phi equal to 2 pi by lambda into x. This relation is known as phi, and 2 pi by lambda is also known as k, means propagation constant. What is x? X is known as path difference. X is known as path difference, phi is known as phase. This is the relation between phase difference and path difference here. So if you want to write here phi equal to 2n pi and phi equal to 2 pi by lambda into x, then we can write 2 pi by lambda into x equal to here 2n pi, pi 2 and 2 pi cancel. Then we can write here x equal to n lambda. What is n? 0, 1, 2, 3. So we get x equal to lambda. If you use 0, then first we get here 0, then lambda, 2 lambda, 3 lambda, and so on. And here we can write, if path difference between two waves is 0, lambda, 2 lambda, 3 lambda, and so on, then we get constructive interference. It means that suppose there is a wave and this is known, this distance is known lambda, and lambda is here, that is 2 pi. This is here phase difference 2 pi. This is y1, and another wave suppose like this, and here phase difference also, this distance is lambda, and here the lambda is equal to 2 pi, and there is phase difference is 0, there is no phase difference. Clear? This is also lambda, this is also lambda, but phase difference 2 pi and 2 pi. So when path difference is 0, and this is also path difference is lambda. So path difference is 0 here, then we get constructive interference. When phase difference is 0 also, 2 pi, if we minus 2 pi, then 0. Then phase difference is also 0, so we get constructive interference. This is the condition for constructive interference. Clear? So in this case we can write here the intensity. Here write intensity I equal to a square, that is I directly equal to a square, or I equal to some constant k. Suppose another one constant, proportionality constant k into a square you can write. So I1 square, this is k1 square. Similarly I2 equal to k a2 square, or we can write a1 square equal to I1 by k. Similarly a2 square equal to a net equal to a1 square, a2 square, 2a1 a2. This is cos phi, and here we have to take square. This is under root and square. Then use, if this relation here, then a1 square you can write I1 by k plus I2 by k plus here 2a1 which is equal to I1 by k under root I2 by k under root, and here cos phi. Clear? Okay, and here this relation we can write a square a square equal to I by k, it is I by k, and k this is root k is equal to k cancel both side, so I net or I which is equal to, this is I net or I, that is equal to I1 plus I2 plus this is 2 I1 I2 and here cos phi. Clear? So this is I net, but here cos phi which is equal to 1. If we use this relation here, so I net equal to I1 plus I2 plus 2 I1 I2, but here I1 into I2 into cos into 1, then A plus B plus 2 into A1 plus A2, or we can write here that is I1 square under root I2 square plus 2 I1 I2, and this is A square plus B square plus 2AB, or we can write here I net equal to I1 under root plus I2 under root whole square. Clear? This is maximum intensity for constructive interference. Now let's start destructive interference. Destructive interference means one crest and one trough, crest trough, then at that time intensity will be 0. So for destructive interference, A net should be a minimum, but A net or A net equal to, we have this A1 square A2 square plus 2 A1 A2, here cos phi, this is cos phi and under root. For minimum amplitude, this amplitude will be minimum. When minimum? For minimum amplitude, then we get cos phi should be minus 1. If we use this relation here, then A net equal to A1 square plus A2 square, here minus, this is cos phi equal to minus, so 2 A1 A2 under root, and this is A minus B whole square. So this is A net. Clear? If here we can write A1 equal to A2, amplitude are same, then A net will be 0. For A net will be 0, here A maximum, intensity will be I minimum, which is equal to 0 if A1 equal to A2. Clear? So here we can write if cos phi which is equal to minus 1, and here we can write it is cos 2n plus 1, and here n equal to 0, 1, 2 and so on. First 0, then cos 1. First if we use 0 here, then 2n plus 1 pi is here, then 0 which is equal to this term is 0, 1, then cos pi equal to minus 1, then use 1 which is equal to 2, 1, then 2 1 is 1 plus 1, that is 3 pi, and cos 3 pi which is equal to minus 1. Same way, so you can write here cos cancel, and phi equal to, and phi is here 2n plus 1 into pi. If we use the value is here, so we can write 0, first use 0, then we get pi, then 3 pi, 5 pi, 7 pi and so on. These are the destructive interference. So when phase difference between two wave, pi, 3 pi, 5 pi, 7 pi, then we get destructive interference. And we have a relation between phase difference and path difference, that is phi equal to 2 pi by lambda into x. If we use this relation here, then we can write that is 2 pi by lambda into x equal to here 2n plus 1 into pi. Then pi is here cancel, then x can be write x equal to, that is 2n plus 1 into lambda by 2. This is general expression. Or you can, if you use n equal to 0, 1, 2, 3 and so on, then x can be write, if you use 0 means here 0, then the remaining term is here, that is lambda by 2. So first we get lambda by 2, then we get 3 lambda by 2, that is 5 lambda by 2 and so on. So if there is a path difference is lambda by 2, 3 lambda by 2, 5 lambda by 2, so we get a destructive interference. This is the condition for destructive interference. Clear? Now if we want to write for constructive interference, phi equal to 0, that is 2 pi, 4 pi, 6 pi and so on, and here x equal to 0, lambda, 2 lambda, 3 3 lambda and so on. This is constructive. For destructive interference, here phi equal to pi, here pi, then 3 pi, here 3 pi, 5 pi, and here this is brightness, we get darkness. This is brightness, darkness, this is darkness, brightness. In this way we get the fringes on the screen. Similarly, here x is 0, constructive 0, then we get here lambda by 2 and here lambda by 2, then lambda, and then after that 3 lambda by 2 and here 3 lambda by 2, 5 lambda by 2, 7 lambda by 2 and so on. Here we get destructive, 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 and here constructive, constructive, constructive. Clear? This is the interference pattern. Now here A net. So A net equal to A1 square plus A2 square plus 2A1 A2 cos phi, and cos phi is here minus 1. So you can write here minus this relation. Clear? Okay. And here this is square relation. Now if we use this relation, we can write I net also here. You can find by using the previous concept here. I net will be I1 minus I2 under root and its whole square. This is I net is here. Clear? So if intensity are equal, then I net will be 0. Another case, if intensity are equal, I net will be increased 4 times. So this is the relation. This is constructive interference and destructive interference. And you can remember the special note. What is I maximum? This is I net or I minimum. We can say I minimum. And is here also. This is I net or we can say A minimum. A minimum, or here amplitude is minimum. So I maximum by I minimum, which is equal to I1 minus I2 divided by, is plus square I1 minus I2 whole square. This is important relation. By using this relation is important. Question may ask in your council examination by using this concept. Find the ratio of maximum and minimum intensity of light if I1 equal to this much and I2 is equal to this much. Clear? These are all about hygiene principle and interference of light wave or interference of wave. Clear? Thank you all.